Hello and welcome to today's Research Collaboration Conference webinar, Automation in Air Traffic Management, the Challenges and Opportunities. I'm your host, Ben Carvell. I'm one of the NATS researchers working on the collaboration with the Alan Turing Institute. And today we're going to be discussing the challenges and opportunities being faced in researching automation and AI within air traffic management. Just so you know, this is being recorded and it will be available on the conference site later in the day. So various levels of automation and AI already exist in air traffic management, and it does play a vital role in supporting our air traffic controllers, especially as historically traffic levels have increased and complexity grows. But how far can we push this? And is it possible to fully automate air traffic control? Well, early this summer, it was announced that a government-backed grant has been awarded to NATS and the Alan Turing Institute to continue research that will explore just this. So Project Bluebird is a partnership between NATS and the Alan Turing Institute with the research vision to deliver the world's first AI system to control a section of airspace in live trials, working with air traffic controllers to help manage the complexities of their role. And so I'm joined today by NATS Head of R&D, Louisa Smith, and from the Turing Institute, Principal Research Data Scientist, Evelina Gabasova. And we're going to talk to them a little bit about what all of this means, where this research is headed, and just a bit more about this exciting project. So Louisa and Evelina, thank you very much indeed for joining us today. And before we start, could you perhaps just introduce yourself and tell us a little bit about your job and maybe what your experience has been with air traffic control and aviation. So Louisa, if I pass over to you first.
Thanks, Ben. So hi everyone, I'm Louisa Smith. I'm Head of Research and Development at NATS, and I lead and responsible for the R&D portfolio and the R&D team at NATS. We have a team of about 32 people, and we work on everything from this environment, so artificial intelligence, data science, and then looking at new airspace users, controller tools, enhancements to the operation so that we can prepare it for the future. So that's kind of the role that I've got at the moment. Previously, I'm an ex-military controller, so I've worked in both tower and en route environment, if you understand that environment. So have done both kind of areas of controlling before joining NATS, and I've done a number of roles within NATS, which included being part of the R&D team as well, working as a project manager on some of the concepts. As well as working as the executive assistant for the CEO a few years ago before coming back to be head of R&D. So that's my background, a little bit of a summary, and I'll pass over to Evelina.
So hello everyone, thank you for the introduction, Ben. I'm Evelina Gabasova and I work in the Alan Turing Institute in the research engineering group. And we've been collaborating with NATS on sort of a pilot project since 2017, 2018. And my background is primarily in probabilistic machine learning and also in software engineering. And together with the whole sort of Alan Turing Institute and the whole academic network, we are trying to bring in our expertise from other areas of machine learning and our experience from other areas into air traffic control. So I would say that a large part of our project so far has been trying to understand each other's language. And maybe, Ben, you can talk a bit about your involvement in the project.
Yeah, so I certainly can. So as mentioned at the start, I'm a researcher in R&D, and I've been lucky enough to be working with Evelina and with the Alan Turing Institute for a few years now. I think it must be at least 3 years, I think, since we kicked off. So we've started out with a small pilot project, which, as Evelina rightly said, it was the primary goal in that was learning to speak each other's language. Really, it was about starting to build that understanding on the NAT side about what's possible with AI and automation, but also to build understanding on the Turing Institute side about what the real tasks of air traffic control are. So that's what I've been doing the last few years, and now a research theme lead for the new collaboration that's just been announced. So I think that leads quite nicely into the next question, really, which is that after this announcement, which is well received. I think that we've got this grant to go and pursue some of this research. I'm wondering if maybe we could just discuss a little bit about a bit more about the structure of the project, what its aims are, what we're hoping to achieve together. So, Lou, do you want to maybe give a summary to kick us off?
Yeah, so as you've kind of all mentioned, that the partnership between the two organisations have been happening over the number of years. It's not something that's just kind of come with this announcement. It's been happening since, as Evelina said, 2017, 2018 time. This kind of partnership is really to establish what you've kind of said, which is really how far can we go with artificial intelligence. And the main kind of objective of the programme is to have an end kind of I'd say prototype or something within the research capability to showcase how, to control a bit of airspace using what's developed through the course of the next 5 years. There's a huge amount of work and a huge amount of involvement from lots of different people to get this successfully underway and to perform the work. And like you said, Ben, it's really about us establishing the collaboration between the two organisations and leveraging off of the knowledge that is known, which is combined within the Alan Turing Institute, getting their understandings from how artificial intelligence can be implemented in other industries and how it might affect our industry, and really developing some of that underlying data science that might help us move forward with this going forward. There's also different elements, as you mentioned. You'll know far more than I do, Ben, on the different streams, but looking at developing a digital twin as well, which is quite significant for us at NATS, and also working with Alan Turing Institute, who have a huge amount of experience in this in other industries, is really essential.
Brilliant. Thanks for that, Lou. Is it fair to say that automation is a big theme for R&D at NATS generally? I think there's a lot of other projects looking in this space as well. Is that right?
Yeah, absolutely. So I think there's, as you touched on at the beginning, there's automation in the operations already. So, there are tools and systems which help and assist the controller in how they can ensure that they can complete their tasks and making sure that they keep everything safe and efficient. There is, whilst at the moment traffic is still kind of low as a result of COVID, we're still anticipating traffic to increase again back to 2019 levels by 2025. At the moment, that's the forecast. With that, we're still expecting that to increase, and we'd still need to be able to develop that, deal with the capacity that we're expecting in the airspace. That mixed with new airspace users as well can really pose a challenge, which gives us this opportunity to look at how we can advance the automation. So the controllers are very much used to automation. There's a number of projects which R&D have been involved in the past that are now implemented. And this is around what new technology might be able to enhance us in the future, enhance the controller, assist in how we can deal with things. So if you think about new airspace users, for example, the amount of data that might be required for a controller to understand around that is really complex. And actually, if we can have systems and tools that can help them to decipher some of that information, that would help considerably in dealing with some of the challenges, not just around capacity, but actually improving the whole system with environmental impacts, which is a huge driver for the R&D team and NATS at the moment as well. I'm just going to say, if people have any questions, feel free to add them into the chat, and then Ben can ask us at the end if there's anything. So whilst we're chatting at the moment, feel free to add any questions.
Yeah, thanks, Lou. Yes, any questions, please do pop them in. We'll get to as much as we can. So
can I chip in on the automation front?
Please do. Yeah.
For me, the interesting problem is not how to automate something that humans do. For me, the interesting point is, can we get the machine to do the stuff that the machines are good at? And can we get the humans just concentrate on the stuff that the humans are good at? So how do we find out where the machine can really make a difference? And I think that's part of this project, basically push the boundaries and find out what the machines are good at for air traffic control, and how can we leverage that together with humans, of course.
Yeah, could we maybe go just a little bit further on that then? So I think the question that is it's a perennial question for air traffic control. Really, is when is the big moment when the switch gets thrown and suddenly everything goes over to the machine? I think it's fair to say that that answer tends to be 10 or 20 years and always be off down in the future. Evelina, could you tell us a little bit about how, in reality, that kind of thing tends to work? Does there tend to be a complete paradigm shift, or do you begin to bring together human and machine operators to build something that's maybe a little more of a smooth transition?
Well, we can look at the parallel in self-driving cars. They obviously operate on a very different principle because planes are not trying to arrange their own path through the sky. Air traffic is centrally controlled by air traffic control, obviously. But it's you can see that there's quite a lot of stuff happening in the self-driving car landscape. And various cars have autopilot mode where the human basically leaves the control to the automated systems. But the human still needs to be in there, able to take over the control in case anything happens. And because this space is not as regulated or as as safety critical, it struggles with keeping the human in the loop in a meaningful way, because the human loses the situational awareness very quickly if they are not actually driving. So we also want to see how far can we go with air traffic control without the human losing situational awareness, because machine learning is very good at doing things that are standard in a way. But it always fails when there is some exceptional situation going on that maybe wasn't in the training data set or didn't happen in the past. And that's why it's important to have the human in control somewhere in the system as well. Yeah, and it really goes to combining the human and machine performance together to get the best out of both.
And I think, just following on from that, that's exactly why something like the digital twin is so key for our work on this, because thankfully we don't have a huge amount of examples of where things don't particularly go as planned, which is great from a kind of a business point of view. But actually, from developing a system like this, you do need data sets like that, and you do need to test whatever you develop and stretch it and challenge it with situations which it may not see all the time. So we need to be able to develop a digital twin so that we can understand and we can replicate realistic data and really challenge anything that's designed and developed through this partnership.
Yeah, that is a very good point, because, well, NATS has been doing a great job controlling the skies, which means there is no data on when things go really wrong. But we want machines to learn that that's not an acceptable behavior. So we have to be able to model it in a reasonable and truthful way.
I don't know if I'm allowed to ask a question, but just for Evelina, when you talk about the controller and autonomy of the controller, is there, there's a lot of ethics as well being talked about in that sense with autonomous cars and decisions and ethics, and I think that's one of the reasons as well where the partnership is good, is that we can learn from and leverage your knowledge on that area. And I just didn't know if there's anything that you might think would be useful or interesting to say about that, because that's quite a challenging area, isn't it, at the moment?
Yeah, that's a good question. Thank you. Well, our program has three main streams. One is on the digital twin, second one is on machine learning control, and the third one is looking precisely at the ethics of the project and of automation in air traffic control. And Edmond Awad, who's the co-I on this stream, has been looking at the ethics of self-driving cars before at MIT. So there is experience in looking at these types of questions in a similar environment. And we definitely want to investigate that as part of this project, because we also acknowledge that people in general are not very comfortable with letting control out of their hands or losing some of the control or just some awareness of what's happening. So we need to see where people would be comfortable to do that, under what circumstances, or how to do that in a meaningful way, and how to get the machines to explain their reasonings to humans. Did that answer your question?
Yeah, I think would it be fair to say, Evelina, that safety is the one thread that draws all of this research together?
Yes, definitely. Well, I think safety is the given, but now we have to bring in other factors, not just compared to safety, but sort of how to get everyone comfortable with how the machine is performing. And that's also the reason why we want to keep the human in the loop as well, because, well, this is a safety critical environment. And it's also part of the research. How can we leverage AI in such a safety critical environment? Because there is not that much research being done in actual real world environments in this area. So I think this is a unique opportunity for the AI community.
Okay. Thanks for that. So a little more about how the project's working then. So obviously it's been quite an unsettling few years for everybody recently with COVID and the advent of virtual working. So I guess just a question to both really, or what's your experience been of trying to set something like this up and get the ball rolling in this new environment that we're all working in? Maybe look at Lou first on this one.
So I think getting anything together at this scale, because it is a 5-year program, 5-year prosperity partnership, that's what the grant is for that we've been awarded, that there is a lot amount of work that goes into that, and there's a huge amount of as expected, challenge and review by the EPSRC to award those things. So there's a lot of work that needs to come together to help us deliver that. I think what helped before is that in 2018, 17, 18, 19, when the two teams working together, that also happened in some instances virtually as well. So we already had that a way of working which was collaboratively, and well, actually, Ben, it's probably best to ask you on that one, but it felt like one big team, and I'm not just saying that to say that for the sake of it. It felt like one big team, and actually in the partnership and getting everything together to put in for EPSRC funding, actually it has felt like one big team that have been working together to try and get to achieve what we wanted to do. And I think that's kind of really how it works. I think COVID and the way that we're working at the moment has meant that we've had to resort to virtual meetings and things more. But as the restrictions have eased, then we're hoping that will mean that we can be working together more closely. And actually our first session all together at the NATS offices is next week. So that's really good to get everyone together again. And I think that will kind of really give a bit of morale boost to the team as well, to make sure that we're all working together and almost kind of have that almost a little celebration together for all the hard work that got put in to get it to where it needed to.
Yeah, definitely. I think we could briefly say a little bit more about that actually. So I think almost all of the activities so far have been undertaken virtually for setting up this project, but we do have a session next week. All of the researchers over at the Turing Institute will be coming down to CTC, not only to meet us, but also to undergo some proper ATC training, courtesy of our wonderful training department. So all of the researchers involved on the Turing side will be going through a very condensed version of the initial ATCO training that we give to all our prospective ATCO trainees. Including, although we can't quite get on to doing full simulations at the end, we're going to do a little bit of playing around with a toy simulator that's been already built as part of the project, just to try and really embed that idea of what doing air traffic control means. So Evelina, we have subjected you to a little bit of this in the past. Could you say how you're feeling about coming down next week for that?
I'm stressed out already. Yeah, I'm a researcher. I'm used to dealing with code and mathematics and numbers, and suddenly just seeing how everything is done, I think it really conveys the complexity of the task of air traffic control. So I'm very excited that everyone on the program will get a taste of what it takes to do air traffic control and how air traffic controls actually operate, how they think about the problem when they look at a screen and see the situation.
And does it help the research to get embedded in this way, to see some of the tasks firsthand?
Definitely. The problem with sort of AI research in this area is that there is a fairly high bar of entry for people to apply any kind of research. So there hasn't been that much research in AI for air traffic control, and I think this is part of the reason. So I think the fact that this program is actually trying to lower the bar and get everyone on board, and not just teach us air traffic control, but also teach people at NUTS about AI. I think it's really sort of mutually beneficial collaboration.
And I think just on your point there, Ben, because obviously you mentioned that other members of the NATS team will be involved in this in some of the training. I think it's important to kind of acknowledge that it's not just the R&D team that are involved on the NATS side, and I know that that's true on the Turing side. There are, you know, financial experts and legal experts who are involved as well in supporting us. And as we go through the kind of program as well, we'll be drawing on different members of the NATS organization to support us as well. So R&D works very closely with controllers on all of our simulations, and we always want their feedback and their input into it. So we'll be, you know, engaging with that community, and we actually already have started to ensure that we've got them involved in their perspective on what's happening and what we're working on as well. So it's important to acknowledge there's a much wider team than just kind of who you might initially think.
Brilliant. Thanks for that, Lou. So we're almost towards question times, but just before we start going to answer some questions, I was wondering if together you could give your view on what are the opportunities from this work. What do we see as some of the potential benefits of coming out of this work, of looking at how we might combine the modern techniques of data science and AI with air traffic management?
So I think maybe I'll just give a higher level, and maybe Evelina can answer some more of the technical side of it. But I think this is really around research, and I think that we need to be really clear about that with, you know, I mean, obviously we're all clear on this given our roles, but actually this is really research, and there's lots of different opportunities with research, and hopefully they end up in being a better, more advanced operations that can deal with different some of the things that we've talked about in the session. But part of it is around the knowledge that we're growing as well, and our understanding of how it might impact the operations in the future. So for me, there's a huge the opportunity is not really known at the moment, because the opportunity will be discovered as we go through some of this program and the work we've already done some work with the Turing Institute over the last few years, which has already helped us get to this point. I don't think any of us could say exactly what the future looks like. I mean, that's the whole point of R&D and research. And I think we're all sat here pretty confident that we know that automation and different elements of automation, which, you know, is machine learning, AI, all that elements, will have a role in ATM in the future. But this whole program is around what that might look like. So there may be huge opportunities, but it's kind of how we meander through this, which will really be important. I hope that makes sense.
Yeah, great. Thanks, Lou. Anything further on that, Evelina?
So for me, of course, as a researcher, there are all these research opportunities. And in general, in academic research, the problem is always getting the data. So I think this project is very unique in that NATS has the data and is making it available for the project. So we have 20 million flight records, air traffic control commands that were issued, the weather forecast, everything. And we can really use that data and learn from it. Then we are creating a probabilistic digital twin of a fairly large scale system. That is exciting. We are looking at the machine learning control from optimization to reinforcement learning. So that will bring in new theoretical advances. And we are looking at the ethics, which I think is very important in a project like this. And overall, we are also trying to attract the attention of the wider research community, because we don't think that we have all the answers. So we will be putting out things like a competition for other academic teams to get their hands on and try their favorite algorithms on, just to see what works best and what can we use. So it's really about bringing out our expertise, but also bringing the attention of the wider community who are not experts in air traffic control, but to present the problems in a way that is where the normal algorithms and the way machine learning researchers are operating in, that it can be applied to this kind of problem, basically to bring in other researchers to the task that NATS wants to get solved.
And just following on from that as well, I think it's, whilst it's from our side as well, from the ATM community, we work in lots of different research projects, with our European partners as well under the Single European Skies Research Programme, and the way that this is set up, that we really want to be able to exploit any findings from this and share it and leverage it off of our other research that we're involved in NATS as well. So there's definitely this bit around, we want to be able to advance the aviation, and we want to do that as a community, and that's what we're trying to create from this partnership.
Brilliant. Thanks for that, everybody. So I think this quite nicely leads in then to the first of our questions that we've had in. So thank you very much, everybody who's put questions in the chat. We'll get through as many as we can. So one of the first ones that's come in here is, what challenges and opportunities do you see in getting controllers to trust the outputs of AI-enabled systems? So relating that to efforts in explainable AI. So as there's the whole of the third pillar of this project, of the three main themes, is dedicated to explainable, trustworthy AI. Evelina, do you want to perhaps maybe say a little bit more about the background of what that theme's trying to achieve, and how that might work?
I think this is a really good question, and it's one of the questions that we are asking. So, for example, in the one theme, we are developing the digital twin, and it will be a probabilistic digital twin, which means that when it's trying to do something like trajectory prediction, it will not predict just one path. It will predict a distribution, showing the most likely path taken and what are the limits and what the probability of each outcome is. So things like that, and putting it into a whole system where the AI would be able to present things like, well, these are the situations that the AI looked at. These are the projections of how that would work out. And this is how certain it is about the predictions. This all falls under explainable AI, and doing explainable AI in the context of a probabilistic digital twin and, let's say, a reinforcement learning system or an optimization system. I think it's there. We just need to look at it, and to put something like that into a mission critical system is part of the research, really.
Yeah.
And
yeah.
So there hasn't been that much work done in actually putting something like this into practice. So we will even be running human studies with air traffic controllers and presenting them with various types of outputs and asking about interpretations.
Yeah, and I think that it will build, what we're this challenge is very, very unique in what we're trying to do, but actually NATS has a huge experience of implementing technical systems, and there's a very rigorous way of we're talking about research here. If we got to the point where we were implementing something, there is a huge amount of safety assurance and management that goes on within NATS, who are, as a company, we've done this quite often. We've implemented systems which aren't the level of automation or AI that we're talking about here, but actually they are automated, and there's a long process before anything would be implemented. But part of that, which, going back to the first question, is that if we compare to how we implement stuff now, there's a huge amount of work with controllers and validations and verification exercises where we're testing the equipment, where we tweak things to make sure they're right, where we test bugs and things like that. So there's a huge amount of work that would happen regardless of what system is going into the operation. So there's a lot of work that we need to look on the AI side, but actually NATS are quite well positioned to hopefully be able to take anything that we develop further anyway.
Yeah, can I just in the Turing we have a lot of expertise in ethics and explainable AI. So yeah, you are right that this is a research project, but there's a lot of expertise in doing explainable AI or research in explainable AI. So this is just sort of a new area to apply it to.
Yeah, I think that sums it up really nicely. To start with, Evelina, we're not looking at safety and trust in isolation. I think it's kind of what you were saying at the start there, that whilst we do have a theme dedicated to it, it's very much about bringing all of that work together and understanding it from, it can't be something just off on its own. It needs to be suffused through all of the research, really, because it is relevant to all of it. But also that we do have a lot of expertise on both sides to draw on, and both NATS's expertise in certifying these kind of systems, but then also as the National Institute for AI, Turing has a significant presence on government regulation boards and that kind of thing in these areas as well. So I think it's a good partnership. On that theme of drawing on expertise, I think that leads quite nicely into the one of the next questions that we've got. So we have what do we have? So we have the best coaches to train machines in unusual scenarios, being ATCOs themselves. Are we using the opportunity of low traffic to develop these agents? So that's a really good question. I think I'll just speak very briefly on this one, and then hand over to Lou and Evelina. But in terms of unusual scenarios, this is one of the big challenges for the project. That, of course, because NATS is based around making sure that everything is safe, there's not a huge amount of data in the real world about what happens when things goes wrong. So obviously that's a challenge if you need a system that you can then prove is going to be able to cope in those kind of scenarios. But as was contained in the question, the best resources we've got is our controllers and all of the operational expertise that exists within NATS for that. So I think one of the primary approaches at the moment has been getting in really early in involving operations, and also training is very relevant. And for this one, with one of the first places that we're going to be looking for this is some of the training that we put our controllers through to keep them fresh on how to deal with all of these unusual circumstances and emergencies. I think so. Whilst we don't have a wealth of data in the real world, because luckily we are generally very safe, we do have lots of very well constructed training scenarios that will provide a really good resource for us to go and start understanding how some of these agents that we build are going to react in these kind of scenarios. So I think it's a really good point there, that there's lots that we can draw on other than just operational data to help us with this. So.
Yeah, and I also think that so it's a really good point around getting information and scenarios, and we've got as we have got access to people who do they do part of this training regularly. Controllers do part of this training regularly to make sure that they're skilled up to deal with any emergency. I guess there's kind of 2 points I would say, is that we only know what we know, which means that actually you might be into a situation where a system and could create a scenario that we haven't thought about. And I think that's something that we have to be really aware of going through this work as well, is that there's lots of examples, and I've used this before, so apologies if people have heard me say this before, but the Hudson Ribbon crash, where if you'd done that a million times on simulations, it wouldn't have happened. So actually, how do we test scenarios which if we run simulations, it wouldn't happen? So we have to really think about that as well. And then on a real practical note is that actually our controllers in NATS are preparing for the traffic to increase. So whilst traffic has remained low, because of the uncertainty about when traffic was recovering, a lot of our controllers are still very much involved in training, and actually, there's a huge amount of the team that are operating normally as well, because obviously you need controllers to be able to control 1 aircraft, 10 aircraft, 200 aircraft. So actually the access to them has not been what is perceived available, because they are preparing for traffic to come back, and to make sure they're still skilled up, obviously.
I can chip in with the research answer to this question, and that is, of course, we are going to use the experience of air traffic controllers, even from the historical records, because, well, of course, there are algorithms that learn from observing examples of behaviors. For example, AlphaGo, in learning how to play Go, first was fed millions of games from sort of historical records and from various online competitions. And that's how it learned how to play the game. So we will be doing something similar for air traffic control, where we will let it learn by observing what humans did in similar situations. And the air traffic control expertise will be involved in all the other areas of the project as well. For example, in designing a evaluation function, how do we evaluate sort of how the AI performed in a simulation? Well, we need to bring in the expertise of actual human air traffic controllers who are used to evaluating the performance. So how can we do it automatically? How can we do it numerically? We need them.
Yeah, definitely. Thanks, Evelina. Just mentioned that we are there's no limits really on who we're willing to learn from in this. There's obviously we have a whole department, and that's dedicated to safety, and they've been kind enough to help us out with some of the early work on this as well. So it's I think everything we can draw on to build a solid foundation for the research, we will. So just time for one last question, I think. So have one come in that says, will this work generate guidelines on explainability and transparency for AI systems within the ATC domain in general, not just for controlling aircraft? So another great question in the realms of explainability, and I think with this one, would it be right to say, Evelina, that it's hard to start on the regulation until you understand what's possible? And I think perhaps there's almost a kind of an iterative nature to this, that with the research that we're building, that we're hoping to build up both sides of those arguments, so both see what's possible and then see what regulation would be necessary to support it. And then obviously we've got our feeders out into what's going on in Europe and the wider world as well to learn from that.
Yeah, I think that's correct, because right now there is not enough research in this area to really know what is possible and what can be done. But in the Turing, we have a lot of expertise anyway in this space as well. We have a sort of, policy group that's put together some ethics guidelines for government on applying AI. So we can collaborate with them later on and produce something like that for air traffic control. But it's not a primary goal of this project. And this is really kind of moonshot project to see how far can we get in 5 years. And then we can expand it afterwards.
Yeah, do you have any further thoughts on that, Lou? Maybe of where there's synergies with other things going on within R&D?
Well, I guess some of the R&D that we do at a wider kind of level, we influences some of the policy and concepts and procedures and stuff that we implement. So in that sense, it potentially will. But I think Evelina's covered it quite nicely there, which is that this is kind of maybe a little bit out of scope on this current project and how we would explore it. But I think to be clear that we whilst we have a very good outline of where we're going for the next 5 years, we might have to deviate depending on what the learning is. So I think we're always like willing to be flexible with what we're working on and how we go forward. So, we can't necessarily assume that it might not change slightly and that might become in scope in the future. So, but it's a good question.
Yeah. Brilliant. Okay, so I think that's all we've got time for on questions, I'm afraid. So anything we didn't answer, we will add up on the virtual exhibition. We'll try and get back to anybody who's asked questions. So please do keep an eye out for that. So it just falls to me now then to say a huge thank you to both Louisa and Evelina for attending and for speaking on what I think is a very interesting topic for all of us. Thanks to everybody who's attended as well. I hope you found it interesting, and thanks very much for submitting all your questions. Some really good questions in there, which show that I think there's some real interest on some of the issues that we're tackling here. So it's great to see you all here, and thanks for attending. If you have any feedback for us or ideas for future work, or want to discuss things that you're working on that might be relevant, that you would like to discuss with us, you can contact us through the virtual exhibition. So if you nip up there, there'll be instructions on how you can do that. Or you could also email us at researchanddevelopment@nats.co.uk. And with that, I'll just say thanks very much for attending, and we'll hope to see you again next time. Thanks very much.